So in this video, we're going to make sense of CAPM graph intuition, especially vis-a-vis the efficient frontier, which essentially is something that you should already master if you're going under the CAPM chapter. What we're going to do now is we're going to do a really quick debriefer or summary, and then we're going to answer a few prompts to get a better feel of what they could possibly ask you on an exam, especially in an introduction to finance course. So as you can see on your screen, we have A to F, a bunch of different questions for the efficient frontier. And then right at the bottom, we have another little graph that I made to give you a better feel of how the efficient frontier actually collides with the CML and obviously also the SML. But for the purpose of this specific question, we're going to look at the CML vis-a-vis the efficient frontier, which typically we would call the new efficient frontier the tangent point. So what I want you guys to be able to understand is how you could use this visual piece of reference. You can even add it to your formula sheet if you want, if you're allowed to do so, and how you can empower yourself to answer these questions. So if we look at A, we're telling you that the tangency portfolio, which is super duper important, so we have the tangency portfolio, we're telling you that that is the point at which you have the lowest standard deviation. Now, once again, what I want you guys to be able to understand is that our efficient frontier is all the different combinations of portfolios mean or expected return to risk. Okay, so you have all the different combinations of expected returns to risk available on your efficient frontier, and it creates this hyperbolic type of line. Okay, so if we tell you that we have point T, which is your which is your tangent point, and we know that point T is right here, but we're telling you that that's the point at which there's the least risk. Already, if you look at your horizontal axis, which represents risk, you clearly know that if we look at our dotted line right here, that dotted line has a risk that is way bigger than our minimum variance portfolio. Okay? So that would be a lie already. Like, it's very obvious to us if we look at a graph that risk is much higher vis-a-vis our tangent point in comparison to our minimum variance portfolio, which is another point on our efficient frontier. We could have taken any other point. We could have taken this point, or something else. But regardless, we would see that, okay, I don't think it's true that our tangent portfolio has the lowest standard deviation being risk. So just like that, just by looking at your graph on an exam, you would be able to see, okay, boom, I know that this is false. There's no way that that's actually factual without even needing to remember something. You can do much better when you actually understand things, and the graph allows you to do so. So already we could see that the tangency portfolio is not the portfolio with the lowest standard deviation. So that would actually be false. Now we have another prompt, which is saying that all portfolios on the efficient frontier have the same Sharpe ratio. So we're telling you that all the portfolios on the efficient frontier have the same Sharpe ratio. First and foremost, although the Sharpe ratio is discussed in our CML, and as you can see right here on your screen, we have our Sharpe ratio. We know that the Sharpe ratio is actually a feature of our ERM minus RF over our OM, which is the risk of the market or the risk of whatever stock we chose. So we know that that's not necessarily the relation to efficient frontier that we think, okay? That's definitely not correct. And also, another thing that we could see on our efficient frontier, and I feel like that's the key takeaway, is that the efficient frontier represents all the different combinations of returns to risk. So you could have a set here and a set here, and you would clearly see that your risk to returns will be different, and your returns to risk will also be different vis-a-vis each point that you take. And I took the liberty to actually give you guys a better proof for you guys, is that for a Sharpe ratio to be the same, they all have to lie on the same line, right? For a Sharpe ratio to be the same, it would have to be on the same line. And already if we look at our graph, it's impossible to have a same line for every point on our efficient frontier, because every line that I plot will give you a different slope, right? Some of them are steeper than others, some of them hit another point, and vice versa. Therefore, it's actually literally mathematically impossible for every single point on your Sharpe ratio to have, on your efficient frontier, to have the same Sharpe ratio. That wouldn't make sense, because they will all have different, okay? Different returns to risk relationships. And if you look right here, I take the time to define that all these points will have different returns and different risk features. Okay, so for that simple reason, we know that this is totally impossible, that all portfolios on the efficient frontier have the same Sharpe ratio. That makes no sense. So, with that being said, we could look at C, and C essentially says that all portfolios on the efficient frontier are attainable. And what they mean by attainable is by saying that something's actually worth your time. It's actually a good, combination of risk to returns. And the efficient frontier represents that to the T, okay? The efficient frontier definitely does that. And if you look at your efficient frontier, whatever's on our pink line, okay, those are all stocks or portfolios that we consider to be attainable. So for that reason, we know that C is true. Now, if we look at D, D says that every portfolio below the efficient portfolio can be improved. So all portfolios on the efficient below the efficient portfolio can be improved. And this is kind of a cryptic question. I'm not even gonna lie to you. It's kind of a cryptic question. But what you want to know here is that typically what we mean is that if something is below the efficient frontier, okay, call it this point right here. So it's below the efficient frontier, okay? Essentially what we're saying is that you could find a better combination of risk to returns that's actually going to yield you a better portfolio. So for example, if we take this point right here, right, we know, we'll call it point X, we know that we could actually have more returns for that given level of risk. So at point M, we could actually have more returns for the same risk, for same level of risk. And that's something super duper important. It's really, really important. So for that reason, when we go back to D, we tell you that every portfolio below the efficient frontier can be improved. Well, that's actually true because you could find another point within your efficient frontier that will give you more returns for that same given level of risk. And that's a really important takeaway. Now, E says that all portfolios on the efficient frontier have the same variance to return ratio. And this is super duper important because it goes back to our question, to our A, okay? It goes back to that idea. It goes back to the idea that when we look at our efficient frontier, we know that every single point is a different combination of risk to returns or returns to risk. Therefore, it's totally false to say that they will all have the same variance to return ratio. That's not the case because every single one of these points have a different combination of variance to returns. So it's impossible for them to have the same ratio. And for that reason, E must be false. Now, if we look at F, F is pretty cool. F says that the minimum variance portfolio represents the lowest level of variance that an efficient portfolio can have. Now, this is super duper simple and it's very intuitive. If you look at your graph once again, at all the dotted lines, we could see that our MVP, okay, our MVP, the minimum variance portfolio, actually gives you the least amount of risk in comparison to any other point that we could place on our efficient frontier. This point will give us more risk, this point will give us more risk, and vice versa, and like as we continue. So with that being said, we're able to see that F must be true. So just like that, you're able to get a way better feel of what the efficient frontier is all about, especially in relation to CAPM and especially in relation to your risk and returns kind of theory and modern portfolio theory, all that good stuff. But what I wanted you to be able to do is identify the key elements of your questions, defining them, looking at your graph, and seeing that, hey man, that question is either super true or so wrong. So with that being said, you're able to just empower yourself to do better on your exam by simply understanding your graph, and especially by understanding the efficient frontier. So hopefully this helped, and I definitely suggest that you look at my other videos which depicts, the different things that you need to understand vis-a-vis CAPM graph intuition. Hopefully this helped.